We will now explore how to design a serial input register. A register is a multi-bit data storage device. Serial data is latched synchronously as the leftmost bit of the register. With each successive latch, the stored data is shifted from left to right. Such a register can be designed from D-type flip-flops. For example, a 2-bit register is constructed from 2 D flip-flops, one for each stored bit. The 2 flip-flops are synchronized by connecting them to the same clock signal. The first bit of the serial input D-in is fed to the D input of the left flip-flop. This input is latched by that flip-flop at the clock trigger. This first bit must be shifted to the right D flip-flop. This is done via a feed line from the Q output of the left flip-flop to the D input of the right flip-flop. At the next clock trigger, the 2 bits will be stored simultaneously. For some purposes, it is useful to shift the data to the left instead of to the right. This is achieved by entering the data in the right flip-flop and then shifting the data from the right flip-flop to the left flip-flop. In a bidirectional shift register, it is possible to shift the data in either direction. This is usually achieved by having 2 separate data input lines, one for the right shift, one for the left shift. We then superimpose the 2 designs. Note, however, that each D input cannot be driven by 2 separate signals simultaneously. Instead, the 2 incoming signals can be channeled by a multiplexer. In our design, resetting the select channel 1 control line to 0 results in a right shift, whereas setting that line to 1 results in a left shift. For this reason, we will call this select input shift left, shift right bar. This is the function table for our 2-bit bidirectional shift register. We note that the output can be obtained from the register either as a parallel output X or as a serial output Dout. It is now possible to construct larger shift registers using a modular approach.